All right, so continuing radical functions. So we're going to graph this. So we're in Desmos and we have this function graphed. We want to graph and analyze each function, describe the domain, range, intercepts, and behavior, continuity, and where the function is increasing or decreasing. So it's similar to what we did with the rational functions. And this one I actually converted to the rational expression because prior to a minute ago, I didn't know how to in Desmos. But if we look at this, what's the domain of this function?
Negative infinity, positive infinity.
All right, so our domain is negative to positive infinity. There is no value that we cannot put in.
Is there what?
All x values work. Yeah.
All values work.
All right, and then what about our range?
Negative infinity to 1.8.
All right, so we're going from negative infinity up to this point, which is 1.71. Now, for that 1.71, do I do a parenthesis or a bracket? Can it be that point?
It can.
So, parenthesis or bracket?
Oh, it's a bracket.
Bracket, good. End behavior. So as we head towards to positive infinity, what's happening to our end behavior?
Goes towards negative.
Right, goes towards negative infinity. And then what about as our x values head towards negative infinity, what happens to our function?
Also negative infinity. 14. Roll your eyes. Dang it. Don't be sassy.
All right, is our function continuous or is there just continuity?
Continuous.
It is a continuous function, no breaks. Now we have a root, so why is it okay? Why can we have negative values? Because what type of root is it? It's a third root. So can we take an odd root of a negative number?
Yes.
Increasing, decreasing. So where's our function increasing?
Negative infinity to 1.71.
All right, so we are increasing from negative infinity to, what's our x value here? 0.
Oh, 0. Wow.
And then from 0 to positive infinity, what are we doing?
Or
0.
negative.
Negative
All right, so we're decreasing.
Yeah, decreasing.
So increasing from negative infinity to 0 and decreasing from 0 to positive infinity. All right, questions with that? Okay. All right, so, and the reason that we have parentheses at 0 is because at 0, at that vertex, it's neither increasing or decreasing. It's the vertex, it's the tipping point, and at that particular spot, it's just there. That's that turning point.
Yes.
All right, the next section says to solve a radical equation, you're first going to isolate the radical expression, then raise each side of the power to the power equal to the index to eliminate the radical. Raising each side of an equation to a power sometimes produces extenuous solutions or solutions that do not satisfy the equations. All right, so let's practice those. Alright, so for 6a we have 3x equals 3 plus square root of 18x minus 18. Alright, So the first thing that we're going to do is we're going to isolate our radical. We're going to get it by itself. So what do we need to move first?
The
3.
The 3. So I'm going to subtract that and put on both sides.
now we need to get rid of the square root.
Now we're going to get rid of that radical. So this is a square root, right? So what's the implied index? 2. So to get rid of the square root, what am I going to do to both sides?
Square it.
Square it. But if I square that side, I have to square this side, correct? All right, now this is a binomial. So when I square this, it's the same as 3x minus 3 times 3x minus 3. And then the square undoes the square root, so we're just left with 18x minus 18. Alright, so now we need to multiply this out. So 3x times 3x is 9x. 3x times negative 3, 9x squared. 9x. So combining like terms. Alright, so now we're going to move this 18x and the 18, we're going to move it over so that our equation equals 0, and then we'll be able to factor to find our solutions. So negative 18x minus 18x is
Negative 36.
Yep. Alright, so I have 9x squared minus 36x plus 27 equals 0. I got that nasty 9 in the front. I'm looking at the terms. Are they each divisible by 9?
Yeah.
Alright, so let's pull it out. Alright, so now I have something that looks friendly. It looks factorable. So what are two numbers that when I multiply them together I get 3, but when I add them I get negative 4?
Negative 1 and negative 3.
Perfect. So when I solve it, x minus 1 equals 0, and x minus 3 equals 0. So I get two solutions, x equals 1 and x equals 3. Now, since we had to square our radical, we need to check to make sure that we didn't get an extra answer. So we need to plug these back into the original to make sure that that they both work.
So when we do that part in that 9 that we take out, what's the part of that 9? Does that just stay
It
out
just
there?
sits there.
So, like, your answer is 1 and 3.
Yes.
And 9 has
And it has nothing to do with it because you took it out of everything. And so if we get x equals 1 and we plug in here, that makes it 0. 9 times 0 is 0 times whatever this is 0. So the whole thing is 0. Same with if this parenthesis is 0, then there's no effect to it. Alright, so looking at 1, 3 times 1 is, may I erase this part here?
Yes.
so now doing our check. So 3 times 1 equals,
So that square root is 0.
okay, so this is 0. So
that
does 3 equal 3?
Yes.
Alright, so 1 works. Now let's check 3. Alright, so what's 18 times 3?
Not a number that I can
36,
tell you off of my
54.
head. 46. 54.
54. 54 minus 18.
36.
Alright, square root of
Technically,
36.
we could have just done 18 times 2. Nice.
What
Okay.
are we doing
No,
We're
check.
checking our work.
Alright, so we're checking because sometimes we get
Every
extra solutions, so we need to make sure that our
Very good.
two are legit. Alright, so does this check?
Just said we don't care.
Ignore it, I didn't hear it.
there?
Alright, so 3 plus 6 is 9, so 3 works as well.
Yes.
So in this case, both of our solutions work.
Okay.
Alright, let's check 6b.
6b.
So,
Take away that.
first of all, yes.
16 times 4. Hmm.
Alright, so here's our problem. So what's our first step?
Minus 3.
Alright, we have a cube
Now I
root.
don't know.
So what do we do?
Oh, you cube
Read it.
Yeah, you cube root it.
We cube both sides. So when we cube a cube root, we're left with just what's on the inside. So 4x plus 8 equals, what's 4 cubed?
64.
Alright, so we're just going to solve. What's 64 minus 8
56.
divided by 4?
This is mine. 14.
Alright, so let's plug it in and make sure it works. What's 4 times 14?
4 times 14 is 56, plus the 8 is 64. And we put it. Cube root is 4. 4 plus 3 is 7.
Alright, so that works. Alright, questions on those?